Hi, everyone. Thank you so much for joining us. We'll get started in a few minutes. We'll just let everyone trickle in. Okay, we'll just give it one more minute and then we'll get started. Thanks everyone for being prompt. For those who have their hands raised, we will get to questions a little bit later. So if you just want to put down your hands for the time being, we're going to go through a number of really important points and probably address most of the questions you all have. So just hang tight.
For folks who are asking about the transcript, you can enable it by clicking on either the 3 dots or 4 squares and enable live transcription. And then you can also, or show transcription. And then if needed, you can also turn it off in the same way if it's taking up too much of your screen.
Okay, we're going to get started. Thank you everyone for joining us. I'm so excited to be here as you're about to start your quantum journey. Today is going to be predominantly an orientation, going over course logistics, getting you introduced to your lead instructors, as well as going over a little bit of content in terms of just at a high level, what is quantum computing and what are some of the applications. So just want to mention that all of the material for this course is for your personal use only. Please do not copy or reproduce or distribute any of the material outside of for your own learning purposes, and that is all. Again, I think a number of you already have been dropping this in the chat, but for any of you who haven't, would love to hear just where you're joining us from. I know we have students all around the world. It's one of the coolest parts of this program. So please, please jump in. So just to get you a little bit excited and in the zone, we love teaching our Intro to Quantum Computing course because there really are endless possibilities for what quantum computing could impact. You all have probably seen, if you're signed up for this course, that there's tons of articles that are coming out on a daily basis about quantum computing, about advances that are being made, about industries and governments that are coming into this space. And what we're most excited about is that you all are really going to be able to be at the forefront of this, and this is the start of your journey. So just to introduce myself, my name's Kira Peltz. I am the founder and executive director of Qubit by Qubit. We have an awesome team who has worked really hard to put this on. Gabby, who is also on the call, is the program manager for all of our quantum programming at the K through 12 level. She will be on many of these calls, as well as will be helping me out as we go through some of the course logistics and overview and adding in additional details. Before we get any further, I want to thank IBM Quantum for their support for this program and many others that we put on, they truly are committed to making sure that the future quantum workforce is diverse, equitable, and inclusive. And we really appreciate their support. You all will, or many of you have received scholarships that is in thanks to IBM Quantum, and you'll be able to have the chance also to hear from a number of people from IBM Quantum throughout this course, which is really exciting. So as I mentioned, we are going to start the part one of today's lecture is really just going to be course logistics, going over the different learning platforms, talking about what you'll learn, introducing you to our team at Qubit by Qubit, and then talking a little bit about expectations and going over our code of conduct. And then the second part, we'll turn it over to Fran and Amir, who are your two lead instructors, and they'll give a high-level overview and introduction to quantum computing. So let me start by just talking a little bit about the coding school. So who we are, the coding school is a 501c3 nonprofit focused on emerging technology education and workforce development training. We have taught over 40,000 students from around the world in approximately 125 countries, with about 55% of our students from underrepresented backgrounds. We're really focused on making sure that the future tech workforce is diverse and inclusive. And so with this program and with all of the other programs that we do, diversity is really the front and center of all of our programming. We're also nationally accredited by WASC, which is the Western Association of Schools and Colleges. So we're actually able to offer this course for high school credit. Some of you on the call may already be receiving credit for this course. If you're not and you would like to petition your school to see if your school will grant credit, we'll have some slides on that a little bit later. So in terms of the three main initiatives that we have at the coding school, one is Code Connects. We do a lot of emerging technology summer camps and programs in data science and computational genomics, in a range of kind of emerging tech fields. Qubit by Qubit, which you all hopefully should know and is what this program is under, is all focused on quantum education, as we do everything from workshops to summer camps and summer schools, professional development for educators, research programs and internship programs. And then our newest initiative is Train, which is funded by the US Department of Defense and is focused on bringing AI and machine learning into high school classrooms around the US through professional development workshops for educators and intensives, as well as a 2-semester Intro to Artificial Intelligence course for high school students. To talk a little bit about Qubit by Qubit and kind of what we value, and these are things we'll continue to remind you about this throughout the course, but really want to emphasize these points now. You're not going to understand everything right away. The field of quantum is new and it's evolving, and we're constantly learning new things. And you'll hear from even experts and our lead instructors. They'll say that there's a lot of concepts that they continue to struggle with, and it takes a long time for them to truly understand. So please be gentle and kind with yourself. If you understand everything, you probably don't. So we would take a humble approach with this, persevere, but just accept that there's a lot of new things that you'll be learning that you haven't learned previously. And so it's okay if you don't understand everything. Second, this really is an inclusive space, and we do everything that we can and want to do everything we can to make sure that you all feel like you belong here. Please let us know. We have a code of conduct, and you can file a report if anyone or anything does make you uncomfortable, we're here to constantly improve. And like I said, make sure that this is a safe and inclusive space for all of you so we can all thrive in this space. Third, and what is most exciting to me is that the future of quantum computing really is in this room right now. Our alumni have already gone on to do incredible things, to be working on incredible research, to get into incredible schools, whether at the undergrad or grad school level. And so you're a part of this community now. You're starting your journey. You or one of your classmates could be the one to make one of the next great discoveries in quantum. And last but not least, we embrace failure, and it really is a part of the learning process. So again, while you won't understand everything, while sometimes things will feel over your head, it's really important that you get comfortable with failing, with not knowing the answer to things and trying again. And last but not least, you belong here. You're meant to be here. This is a space that we believe in you and think that you can thrive in. And we're here to support you in whatever ways that we can to make sure that you're getting the most out of this experience as possible. Now, let's switch gears a little bit and we'll start talking about the course. Before we get into that, just one final kind of quick reminder. You're really doing something that very few people have done before, which is learning quantum with limited prerequisites. This is a evolving field. Our curriculum several years ago, we've had to update because of how much has changed and kind of what's happening in the field now. So this is a difficult subject. There will be things you don't understand that your peers understand. There will be things you understand that your peers don't understand. Just like I said, really embrace the failure, embrace the uncertainty. This is a learning experience through and through, and we've set up this course so that way you can continue to learn and focus on that. Please don't compare yourself to other students. This is about your own journey. And as you'll hear from our instructors and different panelists, a lot of really brilliant people in this field have struggled and continue to struggle with many different concepts. So this is really all about your own journey. And with that said, going to some of the logistics. So this course, for the first time ever, students are allowed to participate in either semester 1 or semester 1 and 2. Semester 1 is going to focus on quantum computing fundamentals. We'll go over a lot of core concepts, whereas semester 2 will start getting into some more advanced concepts, as well as going to quantum computing applications. In total, the course will run through April 16th. If you only signed up for semester 1, but you, as the course goes on, are interested in doing semester 2, we will be accepting applications for students to also participate in semester 2. There are 3 weekly components to this course. The first one is a lecture, which you all are attending now, which is from 12:30 to 2 p.m. Eastern time. While we highly encourage live attendance, it's not required. We will have recordings available that you can watch. It is mandatory, though, that you either attend the live lecture or watch a recording before your lab section. Second, you will have a weekly lab section. Those will be Tuesday through Saturday. This will be a 1-hour lab with a teaching assistant. You'll receive a link to sign up for your lab section next week. These are really a time for your TAs to go into more depth on topics that were covered during lecture. They're also an opportunity for often to work on math problems or to work on coding problems, whereas lecture often focuses on more conceptual concepts. So lab is really where you'll get your questions answered. If anything was confusing, you'll have working on hands-on coding and math problems, and be able to delve deeper into the subject matter with your teaching assistant. And then you'll also have a weekly homework assignment that will be based on lecture and lab. You will have unlimited submissions before the deadline. So these are typically released after the lecture, and they'll be due the following Sunday at 11:59 p.m. Eastern time, and answers will be available after the submission deadline. Already covered a lot of the lecture material, but here it is again. Again, highly encourage you to attend a lecture. One of the great reasons is we'll also have teaching assistants who will be able to answer questions in real time, and we'll also gather questions that many students have, and those will be able to be answered by the instructors. So it's a great time that if you are confused by a concept, you can get real-time feedback and understanding of something that might be confusing. With lecture or with lab sections, these, as I said, will be led by a teaching assistant, which ranges from undergrads through current research scientists and who are in the workforce. You'll actually this will also be held on Zoom, but it will be a separate Zoom link. So don't try to log into your lab section with the lecture link. It'll be a different link, and you'll get that link once you select your lab later this week. So you'll be able to have the chance to select a time that works for your schedule. We also have a number of different labs that you could sign up for. You'll only pick one, but there is an advanced lab, there's a beginner lab, and then we also have some lab sections for students from underrepresented backgrounds, where again, you can opt into this lab section if you choose to. It is really critical for labs. You must attend live. Gabby, there's a certain number of absences.
Yep, all folks get 2 absences for each semester.
And then beyond that, you are at risk of not being able to participate in the course any longer. We find that live attendance holds you accountable and keeps your learning journey on track. So it's really critical that you keep up with your lab sections and you continue to attend. We will be sending out an email for lab signups this week. Please make sure that you fill that out this week, so that way we can match you in your lab sections starting next week. So homework, again, this will be a weekly problem set. It will be based off of lecture and lab. You'll have unlimited submissions, and it'll be released typically after lecture. Now, in terms of course technology, obviously we're using Zoom for all of kind of the live content and for the instruction for lectures and labs. You also will get access to Canvas, which is where all of the course materials will be available, and where you'll also submit your homework, as well as submit your attendance quizzes in your lab section. We will be sending out more information about Canvas. None of you should currently have access to Canvas, so don't worry about this currently. We'll also have a tutorial session where we'll walk through how to use Canvas if you haven't used it before. We will also be using Discord for community building. So this is really an opportunity for you to get to know other members of your cohort. Once you graduate, it'll also be or finish this course. It'll also, you'll have access to our alumni Discord channel. There is a process, and it is in the handbook. So please make sure that you read through that before sending us an email. But feel free to get to know other students in the course. Feel free to ask for help from other students, form your own study groups. We do ask, and it really is important, that you are respectful of other people, though. Please don't make other people feel uncomfortable. Please don't post any insensitive or political commentary. Please do not, unless someone has asked you to privately message them, do not just randomly privately message individuals. Again, we want to make sure that everyone feels safe. And so if at any point you do not, please reach out to us and fill out our code of conduct. Last but not least, in terms of course technology, you all will be using IBM Quantum Experience, which will serve as your coding platform for both labs and homeworks. We also have optional programming support. Like I said, this is optional, so you don't need to attend, but if you are struggling and need additional support, we are here to help you. So we will be having office hours on a weekly basis, where you will be able to drop in and ask any questions that you may have, go over that week's content and review with a teaching assistant. This will be held on Zoom. There will be multiple times to choose from. We also will have a weekly homework review session. So say you're struggling with your homework on a given week, you will actually meet with a teaching assistant who will go over half of the homework problems in that session. You will still need to complete the other half on your own, but it is our hope and our goal that that will provide you with enough support that you're able to complete the rest of the assignment on your own time. All of this information will be announced on Canvas in the next few weeks as the course gets going. So let's go over just a little bit about homework, attendance, and grades. So this course is really meant to be empowering, not a stressful experience. It could be stressful at times or confusing, but it is our goal to make sure that you feel supported as much as possible. Grades are simply a way for us to ensure that you all are accountable and engaged weekly with all of the content. It's not a way that like we're here to test you or compare you to other students. So our kind of overarching principles is the course is pass fail. A score of 60 is a passing grade. These grades will be determined each semester. The way that we've kind of set up grades is that homework will account for 50% of your grade. Again, you have unlimited submissions before the deadline. There's a homework review session where we'll go over 50% of the problems before submission time. Lab attendance is another 40%. So simply showing up for your lab on a weekly basis accounts for a huge percentage of your grade. And then 10% of your grade is completing course evaluations. We have pre and post course evaluations, both from a technical as well as just better understanding, your interest in STEM and kind of other non-technical factors. It's really important that you fill that out for both us to improve our programs, as well as we continue to try to offer as many accessible programs in quantum education as possible, that you all, that we're able to actually go after funding and collaborations that can support that. A few course logistics. So in terms of communication, we will be sending out weekly announcements every Monday on Canvas for anything that needs to be communicated. If you have a question that falls outside of the scope of that weekly announcement, please check the student handbook and FAQs before you ask us or send us an email. If you've checked the handbook, if you've looked at the weekly announcements and there's still a specific question that you have, then please email us at student@qubitbyqubit.org. But please, I will continue to emphasize this, make sure that you check all of the resources that we've provided. We get a lot of redundant questions that could have simply been answered if you did check the handbook. Second, for students who are completing the first semester of the course, we will have a break for Thanksgiving. For students who are taking 2 semesters, we will have a break for the winter holidays from December 18th through January 7th. We will also have a break for spring break from April 9th through 15th. if, need to charge my computer. If your school is interested in offering this as a 4-credit course or as an after-school enrichment course, they can contact us at quantum@thecs.org. And if you as an individual are looking to get this course for high school course credit, please review page 14 of the student handbook. Ultimately, it's up to your school to approve the course for credit. We are happy to talk to your school and work with your school, but you do need to do the initial outreach and give your school the information that we've provided in the handbook. Again, course expectations. Please, please, please read through the handbook before emailing us. Also add the Qubit by Qubit emails to your email contacts and check your spam folders. Our emails can sometimes go into spam, and so we want to make sure that they don't and that you are getting all the communication that you need. We aim to respond to your messages as soon as possible, but responses can take up to 72 hours. So please do not email us repeatedly. We will get to your message as quickly as we can. When you do contact us, do not contact us on social media for anything that is course related. Email us at student@qubitbyqubit.org. That is the only place that we will be answering questions related to the course. And once again, do not share course materials with others outside the course, including the Zoom link. It is really important that our course material remains our own. And so while you will have access to lecture recordings, we do ask that you take notes. We will also send out kind of a recap from the lectures and labs, but we do ask you that you do take notes on lecture content and lab content. Then Gabby, I'm going to have you go through the FAQs while I get my charger.
Yeah, for sure. I know that there are several additional ones that people have been asking in the chat. If you're asking questions, if you could just funnel those towards the Q&A feature as I'm addressing them there. The chat is just a little bit difficult for me to keep up with as we go. You can also see the answered questions that I've already answered. So you might scroll through there and see if your question has been answered, but I'll read through the ones that are up on the slides now. So obviously all of you all can make it to lecture today. So that's fantastic. You made it to orientation. However, it's not uncommon that students aren't able to attend orientation. Like Kira mentioned, we definitely recommend it. So you can ask questions as you have them. We do answer, content related questions, not today, but during a typical lecture. So we encourage folks to attend live, but if you can't make it, that's okay. Many questions about what is happening with labs this week. So just want to remind everyone that you will select your labs this coming week. So you'll be sent a link to select your lab section. We will have optional Python reviews that we'll talk about in a little bit, but no official lab yet. And then if you've only signed up for one semester, but now have decided to take two, you're welcome to reach out to student@qubitbyqubit.org, and we can help you enroll or update your enrollment using the help form as well. You can also find that in your student handbook if you've already read that and submitted it there. We've also gotten a couple of questions about, if I select a lab, does that mean that I'm committed to lab for the full semester or the full year? So we ask that students, when they select a time at the beginning of the semester, that they select one that will work for the majority of the time. We know that students sometimes have things come up. You might get sick or have an event happening. So like we mentioned before, you will have 2 excused absences. However, you should plan to attend the same lab section for the entire semester, with the exception of those breaks that we've already talked about. And then if you're staying for the second semester of the program, you'll have an opportunity to switch at the winter term. And then again, if you have a friend who is still interested in applying, they're welcome to go ahead and apply on our website, the same link that you applied through. So that deadline has been extended through September 24th. So definitely go ahead and reach out to your friend and share that link. And then finally, lots of questions in the Q&A as well. Can you add this course to your college application? Can you share it in job applications or when you're applying to graduate school? You're certainly welcome to. And at the end of the program, you'll be receiving a certificate. So you can include that in any sort of application materials that you're applying for. So with that, I will go back to answering the 67 other questions that we have coming in the chat and toss it back to Kira.
Great, thanks, Gabby. So code of conduct, I've mentioned this a few times. We are committed at the coding school to fostering a respectful, inclusive environment where everyone feels safe and can do their best learning. Examples of behaviors that we believe contribute to a positive learning environment include using welcoming and inclusive language at all times, being respectful of different viewpoints, experiences, and cultures, being an active listener and engaged participant, valuing the contributions of all members of the TCS community. And then this also all includes comments that are meant to be funny or jokes. Again, we want to be respectful and sensitive of where everyone comes from. And so please do not, make jokes that are kind of clouding unacceptable commentary or comments. To report a code of conduct violation, we have a form linked in your student handbook, or if it is incredibly urgent, please email us with the subject line urgent code of conduct at student@qubitbyqubit.org. We also recognize there are students from many different backgrounds and cultures here, and there are different things that are acceptable in different cultures. If you are unsure if something you're about to say or do is acceptable, please reach out to us and we're happy to let you know. We would rather have you take a safe approach than unfortunately have to remove you from the course. So please, everyone, know that we are here to prioritize your safety and your learning environment above all else. And we take any code of conduct violations very seriously. Now getting on to the fun stuff. So things that you're going to have to look forward to in this course. We have fantastic guest speakers, both from industry at IBM Quantum to professors at leading universities around the world who will be able to come and share about their experience, talk about their current research. This is a really fantastic opportunity for all of you to really get to engage with leaders in this space. We also will be having quantum lab tours. In the past, we've had the opportunity to tour IBM's quantum lab facilities, MIT's engineering quantum systems group lab, among others. And so you'll get to see kind of where research is being conducted in these areas. We also, while it's not on here, we will be having some regional meetups so we'll be doing some in-person meetups where we have a significant number of students. And so we're excited to meet some of you face-to-face throughout this upcoming year. For our high school students, we will be having a college panel with our teaching assistants, where they go to school, why they chose to go there, what they've done, what they did in high school to make themselves competitive, as well as all of you will receive a certificate that is signed both by us at Qubit by Qubit, as well as IBM Quantum, that you completed this course, whether you completed the first semester or you completed semester 1 and 2, it'll be 2 different certificates. And now what you'll learn. So we really tried to make the material as comprehensive as possible to give you a strong foundation in quantum computing. In first semester, we cover a lot of quantum computing one-on-one. We go into the quantum stack and how it's different from the classical stack. We spend a few weeks on quantum mechanics. You all will learn how to program a 1-qubit quantum circuit. And again, if none of this makes sense to you right now, don't worry, it's not meant to make sense yet. But I promise by the end of the semester, all of these words will be very familiar to you. You'll also learn Qiskit fundamentals. Qiskit is the IBM's kind of quantum programming language, and we'll start to go into a little bit of quantum algorithms and protocols, and even introduce you to one protocol that you'll actually work your way through that has cybersecurity implications. In semester 2, this is again where we start delving into some more advanced topics, as well as going into applications. So we'll be covering the math for quantum computing. We'll be going deeper into programming and learning how to program 2-qubit quantum circuits. You'll also learn a number of new quantum algorithms and protocols, as well as near-term quantum algorithms. Some of the kind of quantum applications you'll learn is quantum for finance and quantum chemistry, as well as we'll also be discussing quantum ethics and quantum policy. Now, the questions we'll answer in this course, or you'll be able to answer: what is quantum computing? How is quantum computing different from supercomputers? What are the potential applications of quantum computing? How does quantum physics differ from classical physics? How do quantum algorithms and protocols work? What actually are qubits, and how do we know how they behave? How do we tell a quantum computer what we want it to do? How is the quantum computing stack different from the classical computing stack? How do we use quantum superposition, entanglement, and interference to create new quantum algorithms? How could quantum measurement help strengthen cryptography? What big questions are quantum researchers trying to answer today? And then by the end of the course, you'll be able to use math to predict quantum circuit outputs. You'll be able to program multi-qubit quantum circuits, and you'll be able to code on a real quantum computer. And again, if any of this looks scary to you now, don't worry. We will be teaching you all of this and really starting from an introductory level. Now I'm excited to be able to introduce you to our amazing lead instructors, Amir and Fran. Amir and Fran, do you want to just do a quick introduction and introduce yourself?
Sure. Thanks, Kira, for, I guess, leading it so far. So I guess I'll go first and then pass it on to Amir. So I'm Fran. I'm one of the lead instructors this year, and I just started my PhD at UC Berkeley doing research in quantum algorithms. Specifically, I'm really excited about the intersection of quantum computing and machine learning. So if you guys have interest in either of those, or in machine learning specifically, I'd be happy to talk a bit about quantum ML. And I guess just as a bit of background about me, I did my undergrad at MIT, where I actually was first introduced to quantum computing in a class taught by Amir, our other lead co-instructor. And I took that my freshman year, and was just really blown away by how cool quantum computing was. Amir did a really good job of making it approachable, and that got me really excited about quantum computing and led me into the field. So we're hoping that Amir and I this year can kind of do the same thing, get you excited about quantum computing and see where it takes you. So I'll pass it on to Amir now.
Hey, sounds good. Thank you, Fran. Hi, everyone. My name is Amir. I'm a PhD candidate at MIT, and my research is focused on, I guess, broadly building quantum computers, but specifically, I work on experimental quantum computing using superconducting qubits as a platform. Now, we're going to learn a little bit more about the technology going forward, but I'm interested in looking at questions like, for the near-term computers that we have, what can we actually use them for? Can we use them to discover new physics and new material, things of that sort, and actually implementing that in lab? So again, a little bit about my background. Before starting my PhD, I was also an undergrad at MIT, and that's how I met Fran. In the undergrad, I studied physics and electrical engineering and computer science, and my PhD is again kind of a hybrid between the two for quantum computing. So I'm very excited to share my passion really for the field that I've been in for the past 8 years at this point with you guys, and again I'm hoping that you guys get excited or like have at least some amount of excitement by the end of the course.
Awesome. We are so excited to have both of you back teaching. So just so everyone knows, Amir and Fran taught our first ever Intro to Quantum Computing course that ran from fall 2020 through spring 2021. And so we're so excited to have you both back. And now your teaching assistants. We have an incredible team of teaching assistants from a ton of different universities, a ton of different backgrounds and majors, but all with the passion and excitement of introducing you to this exciting field. And then this is our team this is our advisory board. We are honored and grateful to have some incredible leaders in this space who advise us on this course, as well as the rest of Qubit by Qubit's programming. And now course expectations. This is one of the last things we'll go over before we take a short break and then start lecture. But again, be respectful of your classmates and instructors, use the chat appropriately. Please take notes during lecture and lab, as well as arrive on time. Stay focused and on task, and keep your camera on for labs if you're able to, and your microphone muted unless we ask you to unmute yourself, and ask questions when you have them. Also be respectful that if all of your questions can't be answered in a given lab, that's okay. We want to make sure that we're getting to as many students as possible and asking, making sure all students' voices are heard. And then after the course, I know we're just starting off, but we want to make sure that you're able to see that there are some exciting opportunities to come afterwards. So if you're an undergraduate, there are opportunities that will be continuing to expand, like our early quantum career immersion program, which we and internship opportunities for university students in STEM. High school students will also have the opportunity to participate in our high school research program that will happen next summer. And then we have various alumni opportunities, from in-person engagements to special talks to just community building. And so we really see this as an opportunity, just kind of the start of your quantum journey, and we want to be here the whole way through. And now 2 alumni highlights. Gabby, are they joining us or?
So Brian and Sasha won't be able to make it today, but you'll probably see them later on. Sasha on the right here is joining us. She participated in the first iteration of this program in 2020 when Fran and Amir were both teaching it. And she's now a computer science graduate student and returning as a quantum course TA. She'll actually be your teaching assistant. Several of y'all's in the chat. And then on the right here, we have Brian Williams, who just completed the course this past year, is now a first-year CS major who added a physics minor, which is really exciting, after he completed our quantum high school research program this past summer. So these are just 2 examples of really awesome alums, and we have a fantastic, like Kira mentioned, nearly 10,000 students have taken this course. So a really awesome alumni community who are very active in the quantum and STEM world. So we're excited to introduce you to several of them over the course of the next year.
And while we like to manage expectations, this is just an introductory course and laying the foundations, and there's a lot more to learn after you complete this course, whether you do 1 semester or both semesters. We've had high school students change what they've decided to major in or where they've decided to go to college. We've had university students make a complete career pivot. And we've had current members of the workforce actually, one, pivot into this new space, but also we've had people be able to get jobs because an employer has seen on their resume that they have experience in quantum. And while it is just foundational, companies have been interested in having someone on their staff that actually has those experiences. And so again, we're really excited for what you all do after this course and what you use this knowledge for. But we've seen so many stories in ways of how this course has transformed kind of our students' trajectories. And so we're excited to see what you all do as well. And with that said, we're going to take a 5-minute break. And when we come back, we'll switch it over to Fran and Amir, and they'll give the first introductory lecture of the course.
Them to the level that classical computers are today. And they'll give us advantages over the things that classical computers can do today. And of course, it's really important for the future of quantum computing that we have a diverse quantum workforce to really leverage everyone's unique ideas and perspectives in making quantum computers powerful, but also making sure that they're applied to all of the most important settings. And we, yeah, I think just in general, the development of quantum computers will continue to grow much faster if we have people coming in with all different mindsets, perspectives, and ways of problem solving, because it is pretty hard to solve a lot of the problems in quantum computing. There is currently a large quantum talent gap, and by that we mean there's quite a shortage of people who actually know enough about quantum computing to fill all of the interest and positions and kind of research roles that we need in the quantum computing industry and academic setting. So by taking this class, you're really putting yourself in a great spot to join the quantum workforce, which we foresee to grow a lot in the kind of coming years as quantum computers continue to develop and become ever more important in society. And irrespective of whether you see yourself becoming a quantum computing researcher, going into public policy, becoming a climate scientist or a chemist, having knowledge of quantum computing will be super useful. And in fact, even more so, a lot of the fundamentals of quantum computing, ideas from linear algebra, electrical engineering, computer science, will help you in a STEM career in particular, but no matter what you end up doing. So it's really great that you're taking this class as early as you are, and we think it'll help you down the line, irrespective of what job you want. And then Gabby, I don't know if you wanted to conclude by talking about the lab this week.
Yeah, sure. I can touch on this. So as we mentioned before, this week we won't have official lab sections. We will have optional Python review sessions. So if you have never coded before or want a refresher, we'll send out an email tomorrow with specific details of what we'll cover during these sessions. And so you'll know if you'll want to attend or not. But this will be in place of our lab this week. If you already know Python quite well, you do not need to attend. And then in terms of homework, you will have a pre-course survey to complete that will be sent out on Tuesday as well. Brian, can you go to the next slide? Awesome. And those are the announcements that I just mentioned. Before we sign off, I want to remind everyone that the deadline has been extended, and so we're still accepting applications on a rolling basis until next Saturday. So if you are super pumped by this orientation and you want to share it with a friend or invite a sibling or cousin to come join us, please do encourage them to apply by that deadline, although the sooner the better, so that if they are interested, they can get started on complete questions as well. Next slide, friend. Perfect. So we have over 1,000 students on the call here. So I just want to remind everyone that you are well on your way to joining nearly 10,000 alumni who've taken this course and gone on and done really remarkable things in a number of areas, not just quantum. And so we're excited that you'll be able to meet fellow alumni at university, at conferences, and even work who knows how far down the line. So we are very, very excited to have all of you all, and we know that we're going to have just a fantastic year and really awesome community that you all have been a part of so far. It's been awesome to see in the chat how everyone has been getting to know each other in the first few minutes of the call, and we're looking forward to continuing that through the year. I'll let Kira add anything if she has any additional comments.
No, I think we're ready to wrap up. Again, really excited to be here on your journey. As Gabby mentioned, since we did get started late for kind of registration, and we know individuals are just starting to find out about this opportunity still, we have extended the deadline since this week is really an orientation. So please share on social media, share with classmates, share with work colleagues. We want to make sure as many people as possible have this opportunity. And with that said, I'm so excited to be along for the ride with all of you. And if we don't see you this week in one of the Python sessions, we will see you next Sunday in our next lecture. Thanks, everyone.